In this video, we're going to go over setting your working directory, how to import data. We're going to recode a couple of variables, and we're going to go over creating frequency tables. So by the end of this video, you should be able to do your you should know everything that you need to know for your first assignment. So out on Canvas in the Files tab, there is a folder that says data files or data sets or something like that. And inside that folder, there will be a file with your last name on it that you'll want to download and then put somewhere on your computer in a folder that is specific to this class. Then once you have that folder set up with your file in it, then that's what we're going to set as your working directory. Your working directory is where R goes to look for files and where it's going to save stuff. You'll need to do this on each computer that you run your script file on. I don't think that's a big problem for most of us. Most of us are just working on one, but some people have a home computer and a laptop as well. So anyhow, there are a few different ways you can set your working directory. You can, in RStudio, go to Session, which is up here. I don't think it's dramatically different for a Windows system, but it's been a really long time since I've operated on Windows, so I can't guarantee that. But anyway, somewhere you should have this command up top that says Session, and here is the option to set working directory. And you're going to want to say choose directory. Then you'll get a pop-up where you can navigate to your working directory wherever that folder is that you just created that has your data file in it. For me, mine is here. And then once you do that, you see down here that it's just run this setwd command that has set our working directory to that folder that we just designated. You can also navigate to the folder over in this files tab over here. And remember, yours may be down here, or it may be over here or something like that, but mine is up here in this corner. You see I've got my OneDrive, the folder for multivariate 2023 and R code. So over here, you just click on this drop down where it says more and click on set as working directory. And again, that'll set the working directory to whatever folder you have or whatever folder you have displayed here. And then finally, you can just actually run the command. If you know what the path is to the folder that is your working directory, you can just run the command setwd. And then the path goes in quotes, in parentheses. If you're ever unsure what your working directory is, here's the command for finding out, getwd with parentheses behind it. If you run it, then it will tell you down here in the console the path to your working directory. Once you have your working directory set, then we can actually import the data file that you'll be using for this class. There's several packages for importing data. For the most part in this class, we're going to use the package Rio. But today we're going to just take a look at a couple others, in particular because there are some advantages to using Haven, which we'll talk about, but I won't go into in depth. So you'll want to run these 3 lines here to install these 3 packages. I'm not going to run them because I've already installed those packages. And then don't forget that once you've installed the packages, you have to actually also open them. So that's what these 3 lines of code here are. The advantage of Rio is that the import command is the same no matter what the file type. So yes, there are a lot of other packages that'll help you import data, but as we see here, the Haven package uses read_sav to import .sav files, which is file type exported by SPSS. And it's, read_sav, and then you've got to have the name of the file, and then you got to have this extension on the end that says encoding equals Latin 1. So if you run that, it imports the data file. If you're going to import an Excel spreadsheet and you use the foreign package, here's the command. Don't actually run this because you don't have you don't have an Excel file in your working directory yet. So you're just going to, you can run it. You'll just get an error. I actually do have an Excel file saved out there though. So I'm going to run it just to show you that. Why is that different? Probably because that's my last year file, actually. You should have 1,200 observations of 174 variables. Last year, we only had 1,000 observations of 165 variables. And then the reader package you can use to open CSV files, which is just another file type that you'll probably run into quite a bit. Again, here we go. Each one of these is different. These two have an underscore. This one's separated by a dot. This one has this extension. This one's just the file. This one's the file name plus this extension. So that's a lot to keep track of. It's just a mess. Much better to just use the Rio package. So I'm going to actually clear these out of here. Open the Rio library. Then if I bring in, notice for no matter what file type it is, the function is the same. It's import, and then the file name dot the extension in quotes. So I'm going to bring that in. I'm not going to run these just because those were those old data files from last year. You can also export an object to any file type using this function. Export, then your object name, and then give it a name that you want to save it as. So with the appropriate file type. So I can export it as a SAV file. For SPSS, I can export it as an Excel file, or I can export it as a CSV file. Okay, so now you should have the data frame, my data, with 1,200 observations of 174 variables in your environment. Also, if you didn't intuitively do this, clearly you should have renamed all of the file names in this with your own last name, not just left it with mine. Once you have it imported over here, there's several ways to look at the data, although with these larger data sets, it's not super useful to do so. You can use the command head, and then this will return like the 6 top rows of the data. You see that's, lots of variables. Not very useful to look at it that way. For some smaller data frames, this can be useful sometimes. So you will run into it. You can also click on this over here. I think we went through this in the last video, and it'll pop up here as a Excel looking spreadsheet, but it loads really slow. It only shows so many variables at a time, like 1 through 50. So if you actually want to view the data, your best bet is going to be to run this bit of code here, export it as an Excel spreadsheet, and then actually open up the file as an Excel spreadsheet. There's also a command, and actually probably do this and take a look at your data, because it is important to look at the data and kind of get a feel for what's in there. And you might just find it easier throughout the semester to be working with the Excel file. So I would highly recommend exporting to Excel and then using the Excel file from here on out.
I'm not sure I understand.
Siri can not weigh in on that. Okay, so the names function will actually return all variable names in a data set. So names and then the object or the data set name inside the parentheses will return all of the variable names that are in the data set. But as you can see, the names of the variables in the ANES data set are not very descriptive and so not very helpful. So one of the things that we're going to do is rename them to something more useful, along with doing some recoding to get rid of missing data and other weird, quirky things. So before we can actually recode some data, we want to take a look at the variable and see what's in it. So using the table function, we can get a frequency table of the variable to print in the console. So you see this is age. This is respondent age. And you'll see that it starts with age 18 and goes up to age 80. And then it tells you how many at each age that there are in your data set. Now your data is going to look different from mine because Rick generated 10 different data files of 1,200 observations, but just random observations out of the larger ANES data set. I have this -9 here is missing values. Those are people who refuse to answer the age question. So we need to recode those to NA, which is how R handles missing data. It just classifies it as NA. I have 44, but again, you may not have 44. You're going to have something else because all of our data sets are slightly different. You should be able to figure out what this -9 is or what all the rest of the coding is if you refer to the ANES codebook, which is in, where all did I put it? I linked it into the homework assignment, but it's also, if you go out to files, there's a resources and readings folder, and it's in there as well. So you can download it from there and keep it handy. Because you're going to be needing to refer to it quite a bit to figure out what these crazy variable names are. Okay, so we're going to recode the age variable to both be named something more useful and to get rid of the -9 or missing values. And the way we do that is using the if-else function. The structure is like this. The command is, or the formula is if-else, or function, sorry. Then there's going to be a logical test, comma, and then it's going to give you, you're going to tell it what value to populate if the logical test is true, and then another comma, and then the value to populate if the logical test is false. So if you're familiar with Excel formulas, this is a very similar structure to the if function. And you're going to actually take that function and you're going to name it. You're going to create a new variable. So you got your data frame and then the little connector operator there with the $sign. And we're going to call the variable age. Much more useful than V201507X. So we've got that, and then we've got the assignment operator, and then the if-else function. So our logical test is the name of the variable. So if the name of the variable equals -9, then give it the value NA. If it's not -9, so if this logical test is false, then give it the value of whatever was originally in my data variable V201507X. So essentially this function above reads as create an object or variable called myData $age using the function if else. If the variable myData V201507X is equal to -9, then give it the value NA. If not, then give it the value of the original variable. You should also, so I'm going to run that. Notice that we've gone from 174 to 175 variables over here in the global environment. And then you should always double check after each coding to make sure that your new variable matches the old. So if I run both of these tables, a table on the old variable and a table on the new variable, you should see down here that they match. So this -9, this 44 missing values has disappeared because we've deemed that NA or missing. And we can see that there's still 7 18-year-olds, 10 19-year-olds, 8 20-year-olds, so on and so forth. And again, your numbers are not going to be the exact same as mine, but your numbers up here should match your numbers down here, with the exception that your -9s should fall off. So now I'll try another variable with less value categories. Might be helpful to kind of see it a little differently with a categorical variable. This variable here, V203003, is the variable for census region. But what do 1, 2, 3, and 4 stand for? If you refer to the code book, you'll find that 1 is for the Northeast region, 2 is for Midwest, 3 is South, and 4 is West. So we could again use the if-else function to recode these to reflect so that the name of the variable is more useful, but also the categorical values are more descriptive. Since we have multiple values, we have to nest several if-else functions inside of each other to handle all of those values. So this function here is going to read, create a variable named census region, and then you're going to have your assignment operator, and then this reads, if this variable is equal to 1, then give it the value Northeast. Anytime you have text, remember it needs to go in quotes, and then a comma, and if not, then there's a new logical test. If the variable equals 2, then give it the value Midwest. Then if not, then we have another logical test. If the variable equals 3, then give it the value South. If not, we have a final logical test. If the variable is equal to 4, then give it the value of West. And if none of those are applicable, then just give it the value of NA. So a couple things about the above. Notice that we have 4 logical tests if the variable equals 1 through 4. And then we also have 4 values to give if true. We have Northeast, Midwest, South, and West. And then it might look like we only have 1 value if false down here, this NA. But actually, the value if false for the first 3 logical tests is the next if-else function. Another important thing is to pay attention to your parentheses. For each new open parenthesis, you need to close it. So we've got 1, 2, 3, 4 open, so we need to have 4 here. R is pretty useful. Like, you notice that while the cursor is here, it highlights the matching parenthesis here. And if I were to go in just one, why did it go away? There we go. If I were to go into this next one, it gives me this one. And then if I move it to here, you see it drop down to here. And here, it kind of like vaguely highlights that other side of the parenthesis. If you're actually just typing this code by hand, every time you type the if-else command, you see how it kind of pre-populates after the first couple of, if you just click enter, it's automatically going to give you an open and a close parenthesis so that they're already there and you don't have to remember to close it. Again, I better run this. you see we've now gone to 176 variables over here. A couple of important things double check, run the two tables on the old variable, on the new variable, to make sure that they match. Anytime that you have a categorical value, R is going to print it down here in the console in alphabetical order, so just keep that in mind when you match them up. But we can see Midwest is number 2 is still the same, Northeast is number 1 is still the same, South and West, they match. Note in this case that the class of the variables also changed. So originally it was numeric, and it is now a character variable. Also note that sometimes it's easiest to only recode the missing values, as we did with the age variable, and then sometimes it's necessary to recode everything else and use NA as a catch-all at the end. This is kind of an intuitive thing that you'll pick up as we recode more and more. Okay, so on the assignment, you're going to be asked to recode education and income into interval level variables. Years of education and thousands of dollars of income. I'm giving you a freebie here, the income one, just to kind of demonstrate exactly what we mean by that. So again, we're going to use the if else function, but it's going to be much, much longer because there's more values. So the income variable has values 1 through 22. And if you actually look up this variable in the ANES codebook, and I'm actually going to show you, maybe, if it would drag. Here it actually is. -9 is refused. No, -5 is interview break-off, which is another one of their missing variable categories. You can Control F to with the variable name to find it, but I just happen to have already had it up here. And then you see that each category represents a range of income. So category 1 is 0 to 10,000, or 0 to 9,999. Category 2 is 10,000 to 14,999. So what we're going to actually do is we're going to convert this into interval variable, or we're going to convert it into actual numeric values so that it's on a continuous scale. So to do that, what we do is pick the midpoint of whatever the range happens to be. So the midpoint of 0 to 9,999 is 5,000. And since we're doing it in thousands of dollars, we would just use the number 5. And for category 2, the midpoint would be 12,500. So our number is going to be 12.5. For 3, you get where I'm going here, 15,000 to 19,999. The midpoint's going to be 17,500. So we're going to use the number 17.5 when we convert it. So you see I've already got that here set up that way. So again, for each one of these lines, you have your logical test equals where the variable equals 1, the first category, the value to give it if it's true, and then if it's false, you're going to wrap around to the new logical test all the way down, and then you have all of these annoying close parentheses down here at the end. This can be the trickiest part. Many times when you have an error, it's because you're missing one of these, or it's because sometimes really important to remember that R is case sensitive. So if these V's are lowercase, you're going to get an error. It's not going to find it. Or if this X happens to be uppercase, you're going to have an error. But with these formulas, a lot of times what you're looking for is a missing parenthesis. So I'm going to run this, and you see we now have 177 variables. And I'm going to run the table on the old variable and the table on the new variable. And you can see that we've done away with these missing values here, and that we have gone from category 1 to the number 5, category 2 to 12.5, category 3 to 17.5, so on and so forth. So now, rather than these not being very useful, this puts it on a much more useful actual continuous variable scale. Now you should be able to kind of take this same concept and apply it to education, where you're going to have categories like 1 through, I don't remember exactly, 12 or something maybe, and you need to convert that into years of education. So, 8th grade would be 8, high school would be theoretically 12, associate's degree 14, and so on out to a graduate degree. Okay, so the next thing that you're going to be asked to do in the assignment is to create some frequency tables. You're going to be asked to create a frequency distribution for several variables, which should include both counts, cumulative counts, proportions, and cumulative proportions. So we already have been looking at frequency tables in this table function, and we can actually coerce this table that's populating down here in the console into a data frame by using the as.data.frame function. And we see down here we get this kind of nice little data frame with actual headers, variable 1, frequency. And then you can actually create an object out of this so it appears over here in your environment by simply naming it and then using your assignment operator and then copying this formula back to here. And then if we wanted to use the call names function that we learned yesterday, in the previous video, we can actually rename the columns, because what is variable 1, to census region and frequency. Now if we want to just run this again so you can look at it, you see we've replaced the column headers. We can also find proportions rather than counts by using the prop table function, and then actually we have to use the table function inside of the prop table function. So it's not just prop table and then the name of the variable. We actually use the full table function with the name of the variable and then wrap it with the prop table function. And then it'll give you the proportions of each category. And then if we manipulate the data like we did with the counts, you see that I just kind of skipped a step and went straight to naming or creating an object out of it. Now we have this table over here that has the proportions in it as well. And if we want to replace we'll look at this first. So you see again, we have these weird var1 and frequency names, but if we rename them again, look at it, now we've replaced the census region, or the var1 with census region, and then frequency with proportion. So now we have two data frames over here. We have census region and census region prop, and they both have a common variable within it. They both have the census region variable. So since we have those, we can use the merge command to merge these two together on the census region column. So we wind up with a new data frame. Close that, close that. This census region frequency table that has 3 variables in it. And if we look at that, we see it's got the column that has the actual census region, the frequency, and the proportion. In the text, there is this R-Souls tip that mentions the cbind function, which is somewhat similar to merge, except for that it's not quite as smart and would actually duplicate the column that the two files have in common. So if you run this code, you see over here, you can look over here, or you can just run this so it spits out in your console. You see that we have the census region column in here twice, actually. Either way, this is a ton of work, and it doesn't give us those cumulative counts or cumulative proportions that we want. So luckily there's a package that will do all of that for you with just one function. So there is this package called QDAP, and if you want to run that, I'm not going to, well, I think I will actually, because I don't remember if I installed this package or not. And then remember, we need to open it. And the function inside that package that we want is this dist_tab, and then we feed it the name of the variable that we want to see, and then it will spit out this nice little frequency table down here that has the name of the category, the counts, the cumulative counts, the percents or the proportions, and then the cumulative percents or proportions. So the reason I have you do all of this up here is just to kind of show you basically how this function relies on other functions to create this end product. So, this is a lot of work. Somebody somewhere along the lines decided, hey, I want to create just one function, so I only have to do one step to create this thing. So they made a package that has the function in there that has all of the underlying steps kind of operating under the hood, if that makes sense. But all you actually have to do is this one little line of code here. We can do that with the age variable that we created as well. That's a little obnoxious because we have all of these different categories, but it will also give you the frequency, the cumulative frequency, the percent, the cumulative percent for age. If you want to know how many missing variables are in a particular variable, you can use the length function that we saw earlier. But we'll also add another function, the which function, that we will nest, atrocious typing, inside the length function. So this is telling R to return the length of the length of the variable myDataIncome, where the entries are not NA, in which the value is not NA. So the length of this variable in which the value is not NA. So there are 1,100 out of the 1,200 observations. 1,121 actually have data in them, meaning we're missing like 79. Yours, again, will be different from this because we all have slightly different data sets. And then finally, we can take an average of a numeric variable, and you'll be asked to do this on the homework also. But you see, if we just run this code here, we get NA. That's because when you use this function, R does not know what to do with the missing values unless you tell it what to do. So we add this argument after the variable name, na.rm equals true, This NARM reads as remove NAs. And that's it. So you should have all the knowledge that you need to complete the first assignment after this video.